So let's start today's tutorial session. This is session number 4. So we had covered problems based on the load modeling and basic features of power distribution systems. In this session, we are going to solve problems based on the power distribution system reliability indices. So, so before that, the question is based on the following data. So first we will analyze the data, what are the things we have given, and based on the extraction from this data we will understood some of important terms and then we will solve problems based on the given data. So the following things have been given. A distribution feeder is connected to 5,000 customers. The record shows that there are six fault events in a single year. That means the data is given for a single year. The total connected load is 15,000 kilowatt. The total number of customers who experience at least one interruption is 1500. And the following these are the fault events, and from these fault and during these fault events the number of customers interrupted is given in the second number column, and for the duration of interruption for how many hours these customers have been interrupted is given in column 3, and the total load interruption and how many loads that are consumed by these customers have been interrupted is given in this last column. So first we should know the total number of customers served. Total number of customers served, that is denoted by NT. So how many number of customers is serving by this distribution feeder? So in the first line it is given as it is connected to 5,000 customers. So for this total number of customers served is given as 5,000, and the next term is that total number of customers interruption. Total number of customer interruptions. So we usually denote this as summation ni. For this summation ni, this for the different events how many customer interrupted, and for each event, for each fault event, the data are given and we have to just sum up this. From that we will get sigma ni. So summation ni we can calculate from the data as 500, this one 500 plus 700 plus 1000 plus 550 plus 100 plus 200. Sigma ni will comes as 500 plus 700 plus 1000 plus 50 plus 100 plus 200. So this will give you 500 plus 1200 plus 2200, then it will be equal as 2550. So this is the total number of customer interruptions, and last is total number of customers interrupted. Total number of customers interrupted, that we denote as CN. So can anyone tell what is the value of CN? So what should be the value of CN?
1500.
Yes, correct. So CN, the most important point in this total number of customers interrupted, we will not count the customers who is interrupted twice or thrice. Means only once we count. That it does not depend on the number of times interrupted. The customer is counted only once, regardless of the number of times interrupted. So CN is, you can see the last line, the total number of customer who experience at least one interruption. So it is 1500. So in this CN, you can say that the customer is counted at least, the customer is counted once only, regardless of the number of times it is interrupted. So the CN, the customer is counted once regardless of the number of times interrupted. So these are data related to number of customers. So we should know this, the following terms like NT, the total number of customers served, that how many customers connect to the distribution feeder, that is 5000, and total number of customer interruptions, that it should include all the interruptions by each and every fault event. So it is the summation of Ni, and we have calculated this summation of Ni. And the last point is that is very important, total number of customers interrupted, that means CN, and it does not include, means it includes the customer only once, regardless of the number of times interrupted. And if you want to, like in this in this problem, it is directly given, it is 1500. And suppose if you want to, yes, so if in this problem directly given, then you can say it as 1500. And in many, in other questions it is made like that, it is not given. So we usually hard to do, we usually see that the customer interruptions occur once, like whoever is occur once, that we count. So now the next terminology is that the customer interruption duration, summation of customer interruption durations. That is sigma RINI. All of you, please try this customer interruption durations. You have to multiply the duration of interruption with the total number of customer interrupted each event in each fault event. So here R is the restoration time for each interruption event. RI is restoration time for each interruption event. That you can say that is duration of interruption. So we will calculate this customer interruption duration sigma RINI. So first we have for fault event 1 we can multiply 2 into 500, and for second fault event 1.5 into 700, and for third fault event 1 into 1000, and for fourth fault event 1 hour
So
into
3,250.
what? Yes, I did not get your query. Is there any mistake I have written here? And for fifth event 0.5 into 100, and fourth last sixth fault
No,
event
sir.
0.5 into 200. So you will get 1000 plus 1050 plus 1000, and then 50 plus 50 plus 100. So this will gives 1000 plus 3050 plus, then this is 200. So 3250. So the summation of customer interruption duration is sigma RINI, and that will come as 3250. And another data in this problem is given as total connected load is 15,000 kilowatt. So we denote it as LT. So you can write this one also. Total connected load we denote this as LT, and this in in the data it is given as 15,000 kilowatt. And now we will solve problems based on these data we have analyzed. So the first problem is in this we have to determine SAIFI. So you can also solve parallelly with me and type your answer in chat box. SAIFI. SAIFI means System Average Interruption Frequency Index. System Average interruption frequency index. So we define this SAIFI system average interruption frequency index is the ratio of total number of customer interruption to the total number of customers served. So SAIFI is defined as total number of customer interruption, total number of customer interruptions divided by total number of customers served. And we have seen that these are denoted by a specific term. So SAIFI system average interruption frequency index, we can write it as sigma total number of customer interruption, that is sigma ni, the number of customers interrupted during each fault event, that is summed up. So that will give us total number of customer interruption divided by total number of customers served. Total number of customers served we denote as NT, that total number of customers connected through the distribution feeder. So we have already calculated sigma ni as 2550 and NT 5000 divided by 5000. So you will get 0.51. Its unit is 0.51 interruptions per customer served. So the correct answer for this question number 1 is D, 0.51. I am not going to change the data. This data is common for, we will solve today 10 questions, and in each question the data is common to everyone. Just we determine the different reliability indices. So we have calculated SAIFI, and next we will calculate SAIDI. Yes, correct, 0.51. So next reliability indices is SAIDI. So SAIDI is system average interruption duration index. System average interruption duration index. So we say it as it is the ratio of customer interruption duration to the total number of customers served. It is the ratio of customer interruption duration to the total number of customers served. So SAIDI is sigma RINI divided by total number of customers served, that is total number of customer connected to the distribution period NT. Sigma RINI comes as, we have calculated 3250. It should be divided by 5000. So this will give you as 0.65. 0.65 hour per customer served. You can say it as 0.65 hour per customer served. And if you want to calculate in minute, then just multiply it by 60, and then you will get 39 minute per customer served. That in a year, the average customer the average hour, the average minute hour or minute interruption per customer served, that we can calculate by SAIDI. So the correct answer for this question number 2 is B, 0.65. Yes, is correct or no? Now let us see the next problem. Next problem, we have to calculate CAIFI. CAIFI. So CAIFI is customer average interruption frequency index. So let us write the definition of first CAIFI, customer average interruption frequency index. So it is defined as total number of customer interruption divided by total number of customer interrupted. CAIFI is defined as total number of customer interruptions total number of customer interruptions divided by total number of customers interrupted. Therefore, we can say it as CAIFI is total number of customer interruptions, that is sigma ni, and total number of customers interrupted, that is Cn. Sigma ni, we will just calculate the number of customers interrupted during each fault event by doing the summation of 500, 700, 1000, 50, 100, 200. So that will give you as sigma ni 2550. And Cn is just opposite to that of, we will count only once the customers affected at least one interruption. So it is 1500. So this will give you 1.7. So 1.7 interruptions 1.7 interruptions per customers interrupted. So what is the correct answer for this problem number 3? C, 1.7. Yes, 2250, 2550 divided by 1500. That will give 1000, 1.7. And in the next problem, we have to determine the CAIDI. CAIDI. CAIDI is customer average interruption duration index. We have to determine the CAIDI, customer average interruption duration index. Those who are those who have are able to do calculation fast, they can type your answer in the chat box. Customer average interruption duration index. So it is defined as the customer interruption duration divided by total number of customer interruption. So CAIDI is the ratio of customer interruption duration divided by total number of customer interruptions. So we can say, therefore we can say CAIDI is customer interruption duration is sigma RI and total number of customer interruption is sigma NI. So this is CAIDI. So sigma RINI we have calculated 3250 and sigma NI we have calculated 2550. So what value it give? 1.27. 1.27 per hour customer interrupted. 1.27 hour customer interrupt per customer interrupted. If you do want to calculate in a minute, then multiply it 1.27 to 60, then it will give you as 76.2 minute per customer interrupted. And CAIDI is just if you want to do it in other way, then CAIDI is also ratio of SAIDI to the SAIFI. So from there you can also get it. So this is CAIDI. So correct answer for this problem number 4 is 1.27 hour per customer interrupted. So correct answer is A. Yes, correct. 1.2 1.27. Manish and Palvi, your answer is wrong. 1.27 is correct answer. So now let us see the next problem. Next problem is we have to determine the ENS, energy not supplied, and this is load and energy based reliability indices. And earlier we are solving questions based on the interruption indices. So ENS we can say we know that full form of ENS is energy not supplied. So it is defined as just the total load interruption with the number of duration it is interrupted. So it is defined as summation of L average for each fault event. I denotes each fault event into Ri, the number of restoration time for each interruption event. So you can write L average I is average load connected to load point I and Ri is restoration time for each fault event, for each interruption event. Restoration time for each interruption event. Therefore, we can say ENS is summation of L average I Ri. So just we need to do calculation. So during first fault event, one we have total load interruption in 1000 and the number of duration it is interrupted is 2 hour. So 1000 into 2 plus for second fault event 5000 into 1.5 and for third fault event 6000 into 1 consecutively we can for fourth fault event 500 into 1 plus 800 into 0.5 plus 500 into 0.5. So this will give you 2000 plus 5000 into 1.5 is 7500 plus 6000 plus 500 plus 400 plus 250. So 2000 plus 8000 plus 750, so this will 15,500, and the last term is 500, 400, 1150. So it total amount of energy not supplied is 16,650 kilowatt hour. So the correct answer for this problem number 5 is A, 16,650 kilowatt hour. That is total number amount of energy that is not supplied during the interruptions. Yes, correct. Next problem. In the next problem, we have to determine the AENS, average energy not supplied. So whatever energy not supplied, that we have to divide it by total number of customers served. So AENS is average energy not supplied. Average energy not supplied. So it is the ratio of total energy not supplied to the total number of customers served. Average energy not supplied is the ratio of total energy not supplied, total energy not supplied to the total number of customers served. Total number of customers served. So in short form, we can say AENS is total energy not supplied. We denote it as ENS, and total number of customers served, we denote it as NT. NT is given as 5,000 customers. ENS is summation of L average I RI interruption event hour divided by NT. So we have calculated these things. So ENS we have calculated as 16,650 kilowatt hour divided by NT. Total number of customers is 5,000. So this will give you value 3.33 kilowatt hour per customer served. So the correct answer for this problem number 6 is C, 3.33. Till here is if you have any doubt, then you can ask me. Manish, Palvi, Anu, very good. You all are giving correct answer.
No doubt, sir.
Okay, let us move to the next problem. Question number 7. That we have to determine the average customer curtailment index. The following options are given. Just you try it yourself. I am writing down the formula. Average customer curtailment index. So it is the ratio of total energy not supplied divided by total number of customers interrupted. Total energy not supplied divided by total number of customers interrupted. Therefore, ACCI is total energy not supplied is denoted as ANS and total number of customers interrupted that is affected. This be denoted as CN means the customer is having multiple interruption but may a customer having multiple interruption but we will count once only. So total number of customers who experience at least one interruption is 1500. So it is denoted as CN. ANS is L average I into RI summation of L average I RI divided by CN. So we have calculated this energy not supplied as 16,650 kilowatt hour and total number of customers at least experience one interruption is 1500. So this will give you 11.1 kilowatt hour per customer interrupted. So compared to the last value, we have calculated AENS. So in this we are getting more amount of energy. Why? Because means the customers we are calculating this average among the customer who interrupted, and in the last problem we have just calculated average with the ratio of number of customers served. So in the AENS we are getting lesser value, but in ACCI that we are calculating this term with respect to total number of customer interrupted or served, means the customer who interrupted with respect to that we are calculating, so it is coming a larger value. But in the last is AENS we have calculated with respect to customer served with the either he that is interrupted or not, that doesn't matter, means we are taking average with respect to all the number of customer, so in that we are getting lesser value. So let us move to the next problem. So in the next problem we have to determine the ASAI. ASAI is average service availability index. So ASAI is what we can write it as ASAI. In this we have to find it average, so in percentage. So we will multiply whatever the formula we have into 100. So average service availability index. So customers, it is the ratio of customer hour service availability divided by customer hour service demand. So customer hour service availability, customer hour service availability divided by customer hours service demand into 100%. So further we can simplify it. So customer hour service availability is total number of customers served. Total number of customers served into number of hours. The data given for a year. So whatever the number of hours per year we have to multiply based upon the duration for the data is given. Number of hours per year minus customer interruption duration. Customer interruption durations. So it is to customers hour service demand. Just we write the first term of numerator, total number of customers served into number of hours per year. So therefore we can defined we can write ASI as total number of customers served, that is NT, into number of hours per year. So this is 8760 minus customer interruption duration, that is sigma RINI divided by NT into 8760. So this we have to remember it for ASAI, average service availability index. So just put all the values, we will get NT is 5000, total number of customers served, into number of hours per year 8760 minus customer interruption duration sigma RINI we have calculated 3250 divided by NT is 5000 into 8760 into 100. So we all over we multiply into hundreds to getting it in a percentage form. So finally it will give, if you will do simplification, I am just writing it down, 43796,750 divided by 43850 into 100. So you can write it as in per unit, 0 in unit form 0.99 unit hour availability, and in percentage form you can multiply it by 100. That will give you guys 99.99% of service availability. So correct answer for this question number 8 is B, ASAI. Yes, correct. Pedro, Pallavi, Manish, all of your correct. Anu. If you solve parallelly with me, then you will don't face much problem in while solving the assignment. So just try to solve it here. So now let us move to the problem number 9. In this problem, we have to find out ASIDI, average system interruption duration index. So first we will see what is the meaning of this reliability index. So ASIDI is ASIDI, average system interruption duration index. Average system interruption duration index. So it is the ratio of total energy not supplied to the total connected load. It is the ratio of total energy not supplied divided by total connected load. So therefore you can say it as ASIDI is total energy not supplied. We say it as ENS divided total connected load. We just name it as LT. So ENS we can say it as summation of L average I RI is the interruption duration divided by LT total connected load. So we have already calculated these values. ENS is 16,650 and LT is given as total connected load is given as 15,000 kilowatt. So 15,000 kilowatt. So this one is in kilowatt hour and denominator is kilowatt, so it will give you value in hour. So 1.11 hour. So correct answer for this problem number 9 is 1.11. ASIDI is average system interruption duration index. That is the ratio of total energy not supplied to the total connected load. It's correct 1.11. So now let us see the last problem of today's session. In the last problem, we have to determine the customer total average interruption duration index CTAIDI. CTAIDI customer customer total average interruption duration index. So it is defined as customer interruption durations to the it is the ratio of customer interruption duration to the total number of customers interrupted. So it is defined as the ratio of customer interruption duration customer interruption durations to the customer total number of customers interrupted. Therefore, we can write it as CTAIDI as customer interruption duration is a sigma RINI, the number of customer interrupted in each fault event into the number of hour interrupted for each fault event divided total number of customer interrupted, that is CN. So just be careful with this term, that is total number of customer interrupted or total number of customer interruptions. Sigma RINI is 3250 and CN value is that total number of customers who experience at least one interruption is 1500. In this we will not count the customer, we will not count twice if the customer is interrupted twice, we will just one, whoever a customer experience at least one, that will counted in CN. So 1500 means customer who are facing multiple interruptions, that is also counted only once. So CN is 1500. So this value will comes out as 2.1, 2.1667. So equivalently 2.17. So correct answer for this question 10 is D, 2.17. 2.17. Pallavi, Manish, Anu, very good. All of you are doing correct. And it is just if you remember CAIDI, CAIDI, Customer Average Interruption Duration Index, and it is the ratio of sigma RINI divided by sigma NI. We will count all the number of customer interruptions. So in per customer interrupted. And for CAIDI we have calculated value as this one in the final. CAIDI we have calculated value as 1.27 hour per customer interrupted. So that is the we are for calculating CTAID we are getting more values because we are calculating here with respect to the CN term, that is total number of customer interrupted, while in CAIDI we have calculated with respect to sigma NI, that is total number of customer interruptions, so it is having lesser value, while in the CTID that is we are calculating with respect to the customers who are affecting, means who are getting interrupted, so it is having more value as compared to CAIDI. So that's all for today's session. If you having any doubt or facing any problem in solving assignment or any other clarification, you can ask. Thank you all for joining. Anu, do you have any question?
Yes, sir.
Yes.
So, which lecture we have missed, we can watch in recorded form or not?
For this tutorial,
Last tutorial, sir.
yes, it is very easy. Now you can just go to your SWAM portal, and there in the last, like I am showing you, just you see it once. Like this is you have ongoing course, and go to course, and from there you can see in this tab in the last problem solving session you are getting it like this. You can see in mobile also. So just go click on this problem solving session and click here, and you will get this one Excel sheet. So you have YouTube link for all these videos, whatever we have covered problems in the last tutorial sessions. So like session 1, session 2, session 3. And for today's session it will be uploaded by tonight. So it is like that. Did you get it?
So, I have also doubt in assignment question, assignment 4, sir.
Yes. Assignment 4.
So, yes, sir.
Okay. Tell me.
So, I have solved, but I didn't get the correct answer.
Which question?
So, question number 6.
So question number 6. In that question you have to find out the total percentage voltage drops from the feed point to the end point of the main. Right? In this one. In question number 6, that is for hexagonal surface area. Am I right?
Yes, sir.
So you will get the detailed solution for this question also, but I will just tell you that in this problem you have to find out the total percentage drop of the main feeder. So you just write the that formula, that K LE into SN. So LE effective length is 2 divided by 3 times of total length of the feeder L6. So K L6 2 divided 3 L6 into S6. So from there, in this question, that it is not that much difficult. You will get it easily. Just remember that KLE into SN. So LE you have to take effective length as 2 divided by 3. That means 0.66 into length of the feeder. That 0.6 into 2.87 kilometer. And Ka is given as 0.005% voltage drop per kVA kilometer. And S6 is given as 4763.14 kVA. So you just multiply all these values, you will get the answer as 4.56%. Okay, you will get the solution of this, don't worry. Still, if you face problem, then we will try to solve this in next session.
So if we double the number of feeder, then so voltage drop will be half.
Means this is like for uh, symmetrical configuration. Means if you have given hexagonal service area, and in that you have given 6 identical primary feeders, and the substation located at the center of service area, and for the service area of each feeder is triangular shape, like it is having load density is increasingly according to that, because it is triangular shape, and the load of each feeder is 11 kV per third phase. Okay, so what is your question? If
If the
feeder
number of feeders,
what?
if the number of feeders is double.
Okay, in which is means like you are saying that if you don't have 6 identical feeders, you have 12 identical feeders, right?
Yes, sir.
So six, but you cannot like you have to just analyze this. Like how you can just put 12 identical feeders having each feeder service area is triangular shape. How you can put in hexagonal shape? That is the question. Is it feasible that you have extra what you have hexagonal service area for substation, and each primary feeder is having triangular service area, triangular shape? So how you can put 12 number of feeders? Is it feasible? Just think about it, and we will get we will try to see this question again.
Okay, sir. Thank you, sir.
Means like if you think like if you are having substation having hexagonal service area and you want to put 12 number of primary feeders in hexagonal service area, and each primary feeder is having a service area is triangular shape. Is this possible or not? Okay, so thank you all for joining this session, and we will meet on the same time on the next Saturday. Thank you all.